Good evening, ladies and gentlemen. I am Dr. Lizeka Samba. For those who don't know me, I'll be helping you with what is our topic? Is linear and quadratic functions. All right. Today's topic is I don't want to say it's the easiest, but it's one which is an abstract. It's abstract. It's more originated in mathematics itself. So I will see how far I go with helping you on ways on how to think about mathematics as you are studying. Okay, let us start here with linear and quadratic functions. First thing, I'm going to discuss with you the critical aspects that are related to linear functions, according to your thing, to your level. You are supposed to the learning objectives pertaining to linear functions. I start with linear functions, then go to quadratic and do some exercises, and then do some exam equivalent exercises that combine the two. We're supposed to make graphical representation of a linear function, determine the equation of a linear function, and then describe special cases of a linear function. Okay. So what I'm going to first do is to discuss the critical aspects, that is, do a concept mapping of the linear functions. Okay, the linear functions, you find that sometimes they are called straight lines. Okay, you find that you're talking about straight line graphs, or that is a nickname of a linear function. So when you see that you got they're talking about a straight line, you know they're talking about a linear function. So any function is represented in a symbolic form. It is represented in a tabular form whereby you've got coordinates. It is also represented in a graphical form. Okay, so those are the different representations of any function. So now what we are going to be doing, we are going to be translating between different forms of a function. So a linear function, it is mostly represented in a form y is equal to mx plus c. That is your starting point when you're talking about the linear functions. Okay. And another thing, we have to analyze this. We have to analyze the whole. I'm discussing the general principles of linear functions. So now, what you need to know the what do we mean about m, and also what do we mean about UC. Okay. From the keywords, m is about the slope of a straight line, and also c is about the intercepts. Okay. So I'm going to now talk about the m, that is the slope. The m can be is represented in a symbolic form as m is equal to y2 minus y1 over x2 minus x1. These are the things that you need to remember when you are dealing with the concept of a linear function. This is how you would calculate a gradient. You call it a gradient. Okay. And then also you've got you need to know what does a slope mean in a graphical form. If ever you've got a graph, if you've got a graph which is increasing like this, you know that your m is greater than 0. That means the value of your gradient is going to be a positive. Or if ever you've got a graph which is doing this, which is decreasing, you know that the value of your m is going to be negative. Okay, your value of your m is negative. So now that's how we represent when you're talking about the gradient. And then another thing that you need to know when you're talking about the gradient is when you've got two lines. Okay, when you've got two lines, you know, Guti, if ever you are told that the lines are parallel to each other, it means, let's say you've got this one is is for M1, and then this one is for M2. I'm just making an example that you've got two lines here. These two lines, they are parallel to each other. If you've got two lines that are parallel to each other, you know that their gradients are the same. That means your M1 is equal to M2. Okay, so when two lines are parallel to each other, it means this means they are parallel. Okay, and then if ever you've got two lines that are perpendicular, that means this one is intersecting at 90 degrees. When they are perpendicular to each other, two lines, it means your M1 multiplied by your M2 is equal to -1. It means we are talking about perpendicular. I'm going to use this sign. They are perpendicular to each other. So I'm throwing the keywords. This is the language that you need to be aware of when we are working with the linear functions. So now we are done with describing OM. Okay. So after you've described the concept mapping of OM, these are the things that you need to remember when you're talking about two-length or gradient. You need to also identify the concepts, the language that is related to the intercept. So when you're talking about the intercept, you are saying the intercept, that is your C, your intercept is when you're looking at your graph. So here you've got the intercepts. The intercept, how do you calculate the intercept? For your x-intercept, your y is equal to 0. You are using this formula, which is in a coordinate form. And for your y-intercept, your x is equal to 0 and your y is equal to whatever it is. So now this is a general definition of an intercept, how you would find an intercept. Okay, so these are just the ways of describing linear function. Another terminology that you need to know is when this is your y-axis and then this is your x-axis. If ever you've got two lines, maybe this one and then that line, if ever they are intersecting, that's when you are going to be talking about simultaneous equations. I'll also touch on how you would solve simultaneous equations. Okay, and now let us see some few examples which are dealing with the linear equations. One of the examples, this is the first example that I got from one of your thingy lists. So now we want to apply the ideas, that is the concept mapping. This is the question. Now we want to apply all this concept mapping. It's important to open up that concept box. Good, okay, if I'm working with a linear function, this is how I'm going to be answering. This is the tools that I need. So now the slope of a line, you already see when they're talking about the slope of a line, it means this is M, okay? So you are asked for a slope. So I'm analyzing the question first. The slope of a line, already they're saying this is a line. I know a line is described in this form, y is equal to mx plus c, or any other coefficient. It can be ax plus b. So now you are given the points, okay? So now what you need to do here, you need to analyze, you need to say, okay, fine, I've got 2 points. I am going to make this one x1. I'm going to make this one y1. I'm going to make this one x2. I'm going to make this one y2. Okay. Then quickly you go to your toolbox and say, if I'm asked for a gradient or a slope, I know this is a formula that I need to be using. The slope, the formula of a gradient is y2 minus y1 over x2 minus x1. And I'll point out exceptions that you normally find when you are doing this thing. I'll show you the common misconception or an error that is normally done when you are calculating a gradient. You may think it's easy, but it is not easy, especially if ever you have not labeled your coordinates. It's good to always label your coordinates so then you know when you're talking about y2, your y2 here is this one. So your y2 is equal to 3 over 4 minus your y1 is y1 over 3 over your x2 there, it is 2 minus your x1 is half. Okay, what is a common misconception that I want you to watch out for that can make you okay, the common misconception would be, let's say you are substituting that. I'll write it in red. The common misconception would be you write your y2 to be 3 over 4 minus 1 over 3. Ne? And then instead of writing x2, you write x1 here. You've got half minus 2. This is a common misconception that you'd find. So you must always make sure that you are keeping an order. Where the formula is saying substitute for x2, you substitute the correct value of x2, not x1. These are the common errors that you find that you slip between when you are doing this calculation. And then you can get an answer when you are doing this misconception, and you see that your answer is correct. But when you come later, you find that you've got an incorrect, you didn't get any marks because now you substituted incorrectly. Those who've been following me, I always speak about there is a misconception of substitution. Be careful when you're working with anything that has to do with substitution. You can easily make the errors when you're substituting. So I'm not really going to be stressing much here, guys, about arithmetic. You can easily enter this into your calculators, and then when you have entered into your calculators, you will get that. But maybe I should do the I should do the calculation because it's easy. This question is also helping you to remember the fractions. Okay, so now you are dealing with the fractions. Your numerator, you need to be adding and subtracting. So now on your numerator, you are going to get your numerator, you are going to have 5 divided by 12, and then divided by, on your denominator, it is going to be 3 over 2. So this is going to give you 5 over 12. Division can be written as a multiplication, which is 2 over 3. Okay, so this implies that you are going to have, when you cross multiply and divide, this is going to be 10 over 36. If you've got powerful calculators, they can give you this. This is a proper fraction which can be written in your calculator, give you a nice short, because when you look on your answers, you don't have 10 over 36, but your calculators can give you a simplified form, which is 5 over 18, and then you get that. Your gradient, remember we're calculating our gradient, your gradient is equal to this. So what I like about this question, you are not only revising on only one aspect. You're not looking only on the gradient. You are also revising on an aspect of what you call fraction. If you have forgotten your fractions, if you don't have a powerful calculator, because some of the calculators, you can just enter this step and then the calculator does give you the answer. It depends. We don't all have powerful calculators. Okay, so here's another one. Okay, so this question is saying, okay, the equation that described four straight lines are given below. Determine the intercepts, okay, of the x and the y axis for each of the following straight lines. Already, you can see what the question is requiring you to calculate the x and the y intercepts. So quickly you go to your toolbox, that is your concept box, and then you say, okay, what is the definition of the intercept? I know for the intercept, if I want to calculate my x-intercept, I let my x to be equal to 0. For my y-intercept, I let my x to be 0. So this is the principle that I'm to follow when I'm calculating this. So you take those ideas, you apply them here. So now let's say you want to calculate your x-intercept. For your x-intercept, you let your y to be equal to 0. So now you're going to have your y is equal to 0. So you're going to have 1 plus x. So your x is going to be equal to minus 1. That is your x-intercept. And then for your y-intercept, you let your x to be equal to 0. Then you go to your formula here. In your formula, you let your x to be 0 because you're looking for your y-intercept. So you're going to have your y is equal to 1 plus 0. So your y is equal to 1. So your x-intercept here is minus 1 and your y-intercept is equal to 1. This can be rewritten in a coordinate form. You need to know how to write these in different ways. Remember, we are trying to learn a language. So for the x-intercept, this can be rewritten as minus 1, 0, and this one is written as 0, 1. I'm giving you all of these ideas so then when you are answering the questions, when you are given any coordinate, if your coordinate is written like this, you already know what you are given an x-intercept without being told. Remember, in mathematics, it's like for us, it's like Chinese. Chinese is more like a symbolic thing. And then even them, when they're looking in our African languages, if I've written in Xhosa, they think Xhosa is something very foreign. It's like symbols, a lot of symbols. So you know, Guti, when you are entering a discourse of maths, even if no one tells you this is the x-intercept, you know the way it looks, yebo, it is a family of ilento of an x-intercept just by the way it's looking. This one, you know, it is a y-intercept without anyone telling you it's a y-intercept. You can see by the way it looks. Okay, I'll do number 2. You do the same thing for your x-intercept. You let your y to be 0. So now you're going to have 0 is equal to 2 minus 4x. All you need to do here is to simplify. So when you simplify, you're going to have 4x is equal to 2. So therefore, your x is equal to half. For your y-intercept, you let your x to be 0 in this formula. So you're going to have y is equal to 2. You just substitute your x to be equal to 0. Write this thing in a coordinate form. Your x-intercept is written as half, 0. Your y-intercept is written as 0, 2 without anyone tells you so. I'm not going to do number 3. I hope you can see the flow on how we do these calculations. Let's look at this question. Okay. What is important is to go and open your toolbox. Your concept mapping is very important. You must remember what is the definition of the concepts, okay, that you are dealing with. So let us read this question. This question is saying, determine the equation of the straight line through the already. You know what a straight line is y is equal to mx plus c. So now y is equal to mx plus c. Okay, so now we have to look for an equation of a straight line, which is y is equal to mc. We are given the points. Okay, so now what do? You said, okay, fine, let me go to my concept mapping. Okay, my toolbox. I open my toolbox. What is an equation of a straight line? An equation of a straight line, I know it is looking like y is equal to mx plus c. Okay, that is the equation of a straight line. And now I am only given the points here. So for me to get what they are looking for, I need to find my m, and I also need to find my c. Those are the only 2 points. So now you go and say, okay, how do I calculate my m? Do I have enough information to calculate from my m? You go and look further. What is it that you have given. You are given the coordinates. Once you're given the coordinates, you go and label them. You have not done anything. You are just doing an analysis of the information. So you just go and say, this is going to be my X1. I'm just labeling it. This is going to be my Y1. This is going to be my X2. This is going to be my Y2. So now this is going to help me to find the UUM. Okay, so now you go and say, okay, fine. I know from my toolbox, my M is equal to these formulas to help you with your substitution. Y2 minus my Y1 divided by X2 minus my X1. All right. And then you say, okay, fine. What is my Y2? I've already labeled. Okay. So you know what, you've got everything, you have labeled, you have done your analysis and highlighted things to help your brain cells make it easy to calculate. So I know what is my Y2, I've labeled it. It is 3 and my Y1 is equal to, my Y1 is equal to 2. My X2 is 3 minus my X1 is equal to 1. Okay, this one is easy. My gradient is just equal to, I don't need to highlight anything here, any misconception, because we don't have to deal with any fractions. So I'll just, you can just do it, this thing without, this is just equal to half. Okay, that is your gradient. And then you said, okay, fine, I've got my gradient, but I don't know what is my gradient, my intercept. That is your y-intercept. Okay, remember your C is your y-intercept. Okay, so now I know what my y is equal to x plus c. Then you quickly go to your toolbox and say, what is a definition of a y-intercept? A definition of a y-intercept is saying, for my y-intercept, my x is 0 and my y is whatever. So I'm going to use this definition. You always consult your toolbox because now you want your C. So here you are going to say my y, if you do that, okay? I am giving counter examples so then you can see if you are going to follow this strategy, it may not work. Okay, so if ever you let in this formula, you let your x to be equal to 0, you are going into what we call a circular argument. You are going to have a value of y is equal to c. You understand? So now this strategy will not work in this instance, guys. Okay, in this instance, this is not going to work for you. Okay, so now it's not that it is incorrect for you to open that toolbox, but it is not economically for you to use, because once you substitute your x to be equal to 0, you are left with y is equal to c. What is that? It is just telling you that your y-intercept is equal to c. So in a case like this, how do you calculate for your C? So now the idea is saying, go to your coordinates. You've got these and this. Take any one that you like and substitute for y and for your x. Choose anyone. Let's choose these ones. Okay. Let us let our y to be equal to 2. Okay. And then half. And then let us let our x to be equal to 1. And then we want to find your C. This is a strategy, guys, that you are going to apply anytime you are working with AMA functions, irrespective whether it is a linear function or it is quadratic or it's hyperbola. This is the strategy that you use. Okay, I may not go through all the functions, but look at what you are given, you apply the similar strategy. It does not matter what kind of function that you are working with. So here you find your C, you find that your C is equal to, you do your mathematical manipulation, your C here is going to be equal to 3 over 2. So you've got your C and your M, you go and substitute and say your Y is equal to x plus 3 over 2. That is the formula. That is the equation that they are looking for. If you can decide, you don't really have to use this one. You could have decided to use this one. You would still get the same equation. You can try that. It's not going to take you long. Let's try it. If we are going to try these coordinates, we are going to have you substitute this coordinate here. Okay, so here you're going to have 3 is equal to half multiplied by 3 plus c. So when you simplify, you'll find that your c is equal to 3 over 2. I'm not going to go through that. So you don't really have to choose the first coordinate. You can choose the second one. Okay, anyone that you've got access to. Okay, so now here is the formula, the formula that they are looking for, the equation. This is the equation describing this relationship between these coordinates. So now we move to B. UT, find the intercept. I've already done that. Okay, this is what we have done. We have find the y-intercept, and then we have also find, if you want to find the x-intercept, you find it after, you can find your x-intercept in this formula. Okay, how do you find, I mean, your y-intercept is already this one. We have found it. If ever you want to follow the strategy, this strategy, you can do that. You can do this one to answer number B. Okay. To answer number B. So here, so for your y-intercept, it's going to be 3 over 2. You're going to enter your x to be equal to 0. For your x-intercept, you're going to enter your y to be 0. You let this one to be 0, and then you're going to find that your y-intercept is equal to, your y-intercept is 3 over 2, and then your x-intercept, what is your x-intercept here? Your x-intercept, it is equal to -3, okay? And the question is saying, we go to number C. If you've got any questions, guys, please ask. But this is the way that you are going to be applying this thinking. So in the line that you have found, okay, this is the line that we have found. We're asked to find this line. Okay, in this line, you are given this line, and then you are asked, is this line parallel to y is equal to 2x plus 2? So now we are asked to decide whether y is equal to 2 plus x. Okay. So if you want to decide, you can rewrite this as y is equal to x plus 2. Okay, this is the same as this one. Remember what we said from our toolbox? We said 2 lines can only be parallel if ever their gradients are the same. Otherwise, if ever they're not the same, then you can't talk. So now you look at this gradient, the gradient of this is half. The gradient of this is 1. Half and 1 are not the same. So therefore, the 2 lines are not the same, are not parallel to each other, because they do not have the same gradient. We are just applying the concepts, the concept language. Okay, so that's how you would answer number C. Okay, so now the question now says, draw the lines A and C on one graph. I've tried to draw these, and I don't draw a nice, because I was not using a graph paper, but I've used online software, so then I can demonstrate. After you have drawn your thing, for you to be able to draw these, you don't need to be worrying. You just need to get your x-intercepts and your y-intercepts, and then you draw the line. And then after you have drawn those 2 lines, you will see that they are not parallel to each other, of course, because they are intersecting at a point. Okay, this is the point that they're intersecting. this is a point which we are calling OA. Okay. So now this is another proof that those two are not parallel to each other, they intersect. Okay, and now I wanted to add, because I wanted to do many things with this question because it is opening up many opportunities. There's an opportunity of doing simultaneous equations here. Okay, so I thought, okay, let me grab this opportunity and find the solution. When you are looking for where two lines are intersecting, you are solving the two equations simultaneously. So now we want to find these coordinates. Graphically, we are going to get an answer 1, comma, minus, comma, 1, comma, 1. This is a solution that we want to prove that A is indeed equal to minus 1, comma, 1. However, I want to take up this opportunity to help those who are struggling with how to calculate, how to do simultaneous equations. It's another part, the topic that you need to do. How you calculate simultaneous equations. I will take you through how you calculate simultaneous equations by elimination and also by substitution. You apply the similar method whether you are doing hyperbola or quadratic, the same strategy. So now let us prove that point A is minus 1, comma 1. Okay, so now what we are going to do now, we are going to take our two equations to find the point A. So now we are going to have y is equal to half x plus 3 over 2. I'm going to let this thing to be my equation 1. Okay, the second equation, your y is equal to x plus 2. This is my second equation. Okay, I'm going to first take you through on elimination method. When we are eliminating, you need to eliminate one variable. Okay, here you've got two variables. One is x and another one is y. On the two equations, you want to eliminate one. When you are going through an elimination method, you need to make sure that one of the variables that you want to eliminate have got the same coefficient. Okay, if they don't have the same coefficient, you need to make sure that you transform that equation so then it looks the same as the other one. How you transform, you can do whatever. You can multiply it by a specific constant across. Okay, lucky enough on these two equations, we want to eliminate, it's easy to eliminate y because OI has got the same coefficient. That is rule number 1. For elimination, one of the coefficients that you want to eliminate must have the same coefficient. So OI have got the same coefficient, so I can easily eliminate. How do you eliminate? I'm going to subtract one from the other. Okay, so I'm going to say equation 1 minus equation 2. Okay, that is the rule that I'm putting. I'm eliminating. So now let's start with our equation 1. Y minus y is equal to 0. This is going to be equal to 0, which is equal to half x. Half x minus x. Half x minus x is going to give us minus half x. Okay, and am I right? You're right, ne? Then 3 over 2 minus 2. 3 over 2 minus 2 angiyazi. 3 over 2 minus 2 is equal to half. So now this is going to give us minus half. Okay, so now once you've got this, you can just apply your mathematics calculation. So now your x is just going to be equal to 1. Am I correct here, guys? Minus 1. Your x is minus 1. Okay, you've got your x. Remember, this is an elimination method. Once you've got your x, go and take your x and substitute it in any of the two. You can substitute it in your 1 or you substitute it into your 2. Anyone that you feel in love with that is economical. I think you must economize with your time. So I think it's better to substitute this thing here because it's easy. You can even do it by inspection. So now you substitute your x is equal to minus 1 in 2. So you're going to have your y is equal to minus 1 plus 2, which is going to be equal to 1. Therefore, your point of intersection is minus 1, 1. So we have proven good indeed. Your point of intersection is minus 1, 1. Through elimination, you do this method whether you are doing quadratic equations or hyperbola. If you are looking for any points of intersection, you would follow this method. If they are asking for you to do elimination method, let us do a substitution method. A substitution method, Yona it for you to substitute, go to your two equations. Okay. Go to your two equations. These two equations, I am starting here. I'm not going to rewrite. I am starting here. Okay. This is was my half. And then this was my x. So I've named them this. This is I'm coming back here. I am not using elimination method, but I am doing substitution method. Substitution method is saying take anyone and substitute it into the other. Okay. It is advisable to take the one which looks simpler and substitute it into the one that looks a little bit complicated. Okay. So now here we can take 2 and say, take 2 and substitute it in 1. I'm doing substitution method. Okay, so now here I am going to have, this is your y. This thing is saying y is equal to x plus 2. It's saying wherever you see a y in 1, substitute the value of y, which is x plus 2. Okay, so now I'm doing that. So I'm substituting my y, this value, into this y. So I'm going to have my x plus 2, which is equal to half x plus 3 over 2. And what I do next is I simplify, okay? And then after simplifying, you would find that you are going to have half x, half minus half is going to be equal to half x, 3 over 2 minus 2, minus 2 is going to be equal to minus half. So therefore, my x is equal to minus 1. You still get the same value. I'm just showing you different methods. It will depend what you are asked. So now, once you have found one value, you can take this value and substitute it in any of the two. So then you can find your y coordinate. So we can take that x value and substitute it in any one. Right now, you don't have to be worrying. You can choose any one that you like. So if you decide to substitute it in this one, you are going to find that your y value is equal to 1. So now that is how we would talk about substitution and elimination. I hope we will be coming across some of the examples which require us to do quadratic functions and see if these methods do work. You will make your own judgment. Use the method that is working at that point in time. You don't have to use elimination when it's easy to do substitution. You don't need to use substitution when it's easy to do elimination. So you have to make up your mind which method that is economically at that time. Okay, now let us go and talk about quadratic functions. Okay, there's nothing more that you'll ever find on linear equations. This is the gospel of the linear functions. They get interesting when you combine them with quadratic and or hyperbola. So now let us talk about Ilento, like about the gospel of a quadratic. What is the concept mapping of the quadratic function? Okay, the quadratic function, what you are expected to do at your level. Okay, I've seen some people when they are doing these things. If you know Ilento, if you know calculus, derivatives, if ever you are looking for a gradient, no, let me not confuse you right now. Let us do this, the concept mapping of quadratic functions. I will highlight where you can bring in calculus. Okay, so now here, what you are expected to know, you need to represent a quadratic function. Hello?
Hi, Vincent.
Yebo?
Okay, going back there, or when you substitute equation 2 into equation 1, just a bit.
There's the last one.
Yes.
Yeah.
Isn't it that? Oh, okay. Okay, now I see my mistake. I thought maybe I did wrong. All right, thank you.
Remember, your y is this one. You substitute the whole thing here.
Yes.
Okay. Sharp.
So
it will be helpful to do more examples which you do these things, so then you don't have to come back when you're doing exams and practice this thing. Quadratic functions, you need to represent this thing graphically. You need to explain the different characteristics of the quadratic function, determine the intercepts and the vertex of the graph of a quadratic function. Okay, what is a gospel about this thing? Remember, a gospel is something that is what is a gospel truth? What are the truths that will never change? That is your concept mapping, your toolbox. What do you find when you open up a toolbox of quadratic functions? First thing, when you're talking about quadratic functions, there are three forms that we need to think about. Okay, the first form, okay, we can talk about the standard form. Okay, first thing, a quadratic function, it is a function which looks like this. Okay, sometimes it can look like this, something like this. Okay, anything that looks like this, is a quadratic. Another name of a quadratic is called parabola. This is a parabola. Okay, so something looks like this, good, I need to go and open up a toolbox of a quadratic function. So now there are three forms that I'm going to share with you that you need to have on your toolbox. That means you need to always open up a standard form. Okay. A standard form of a quadratic function, it is y is equal to ax squared plus b plus bx plus c. This is the most one that we see. What is important is, what does this represent? Okay, this represents that the things that you can read. What information is it giving you? Your quadratic form, if ever you've got an equation, if your thing is in an equation form, what it suggests is, if ever your a is greater than 0, that means if your value of your a is positive, it means you are going to be having a graph which is smiling. We call it a smiling face. My high school students, they call it a smiling face. Your parabola is going to be looking upwards. And then if ever your thing is negative, your thing is going to be frowning. They call it frowning. Okay, that means it is looking downwards. Those are the things that are suggested by your A. So it is important for you to know how to interpret the equation. Okay, so what else does this represent? This represents your C is your y-intercept. I'm trying to develop a concept map here that I can always remember. This will be your concept map. And then what else do you get here? You get that we know in Toguti every time you are working with a parabola, it looks like this. A parabola has what we call axis of symmetry. That means there's that line which is dividing your parabola into half. This is your axis of symmetry. Also, you can get the axis of symmetry if ever you are given a quadratic equation in this form. So the formula for the axis of symmetry is x is equal to let me start with okay, it is x is equal to minus b over 2a. These are the things that you need to remember when you are using this. So now, if ever you've got this, you can get your axis of symmetry. Your axis of symmetry, it means you're getting the x coordinate of your turning point. Your axis of symmetry is when your graph is turning. That means where it is turning your turning point, and is specifically giving you the formula for your x coordinate. So now that x coordinate can be substituted back to your original equation, so then you can get the y coordinate, so then you can get the points of your turning point. So this is a formula that you can find for your axis of symmetry that is suggested by this formula. And what else? The x-intercept. The x-intercept is when your graph is cutting your x-axis. Okay. So sometimes you find what we call these the zeros. Okay, when you find a question that is saying find the zeros, you know you are looking for your x-intercepts. So the formula for the x-intercept is the one that is famous, that we always know, minus b plus or minus b squared minus 4ac divided by 2a. This is the formula that you would use when you are trying to solve for your x. So this is divided by 2a. Okay, so this is for your x-intercepts. Okay, for x-intercept, this is what the formula that you would use. So this is what it's suggesting. And then what else does this thing suggest? This thing is suggesting when you look here inside your radical sign, there's this formula. We call this formula a discriminant. A discriminant is equal to b squared minus 4ac. Okay, so when you're discriminant, what does it tell you? A discriminant is saying that if you get you want to check how many solutions are going to have, are you going to have real solutions or no solutions at all? Your discriminant, if it's greater than 0, what do we mean? If you substitute your b, your a, and your c, you find the value, it is positive. If your value is positive, it means you're going to get 2 real solutions. That means 2 x-intercepts. That means your thing is going to be doing this. Okay, it means you're going to have 2 x-intercepts if your discriminant is greater than 0. If your discriminant is equal to 0, okay, it means you are going to have 1 real solution. That means there's only going to be 1 real solution. So your graph is going to be looking like this. It's going to be touching at least 1 point. Okay, that's when your discriminant is is equal to 0. When your discriminant is less than 0, it means you are not going to have any solutions. What do we mean by that? We mean your thing is not going to be touching your x-axis. It means your thing is going to be flying there. Okay, so it is not intercepting your x-axis. Remember, this is your x-axis, this is your y-axis. So it is important for you to know these terms. This is a terminology. Those are the critical aspects about a standard form when it's written in this form. Okay, and then we've got another form. Another form of a quadratic is the one that is called a vertex form. So there is a vertex form. A vertex form is when you've got a quadratic equation which looks like this. This is a into x minus h to the power squared plus k. Sometimes you can get the quadratic equation in this form. You can get the properties of your quadratic here. This thing, what it tells us is you can get the coordinates of your turning point. I'm going to put TP for my turning points. The thing for your turning point, you only take this, which is your H and also your K. So you don't have to go and calculate your turning point. You can easily get your turning points. Okay, and then what else does this suggest? It also gives us information about the axis of symmetry. Okay, so the axis of symmetry is when your x is equal to h. So this one, if you take this thing and equate it to 0, you will get your axis of symmetry. So that's about it. The vertex form, when you given this your quadratic equation in this form, you only get two information. One is a turning point, one is your axis of symmetry. Be careful. Your k does not represent your y-intercept. Okay, so don't make that misconception and think this also represent the turning point. No, it is a y coordinate of your turning point. Okay, what is another form? You've got another form which we call an intercept form. Okay, an intercept form is in a form y is equal to a into x minus x1 into x minus x2. Okay, so this is an intercept form. Sometimes you'd find your quadratic in this form. What information does it suggest to you? It is giving you the x-intercepts. That's the first thing that it gives you. That's what makes it unique. So it's giving you the x-intercepts. Your x-intercept will be your x1 and your x2. Okay, so now this value is going to be for your x-intercept, and this value is going to be your another x-intercept. Why it's important for you to know the three different forms is for you to know, if I'm given x-intercepts only, how can I use the standard form to get the standard another standard form? You can translate between the three different forms, but your module, you are not expected to reproduce this like this one. Okay, this one you can get from this one. You can translate from the standard form to this one. We use a method which is called completing a square, but we are not going to do that. It's not for our expectations at this level, whereby we go and reproduce this one. But you can get this form from this form. Okay, just be aware. So what I've done here is to present to you the different forms of a quadratic. So now what is left for us now is to say, okay, fine, why should we care? Okay, you should care because this is your toolbox. Okay, so now what we need to do, because now you've got your toolbox, these are the critical aspects. What do you do with these critical aspects? You go and apply them in problem solving. So we are going to be attending to different examples, so then we can see the strategy and the procedure of solving these. Okay, here's one example that I found. Okay, this example, you are given a quadratic. We know it's a quadratic, we are told. This is a quadratic thing. It is given in this form. At the same time, information is also given in a quadratic. Let's analyze the given information. It's always important to analyze what is given. Okay, what is given? You are given the turning points. Okay, your turning points, the coordinates of your turning points, it is -2, comma 10. That is your turning point. And we also know the axis of symmetry, your x is equal to -2. And what else do we know? We also know what is our y-intercept. There is our y-intercept. So our y-intercept is equal to 6. Okay, we can see our y-intercept. Okay, we can see the x-intercept, but now it's difficult for us to see because they are not whole numbers, like about 1, 2, 3, 4, 5. But we can see. But what is it that you can tell about this? If you were to go back to our analysis of the discriminant, we said if ever your discriminant is greater than 0, it means now you are going to have 2 intercepts. This thing has got 2 x-intercept. It means your discriminant is greater than 0. That means it is positive. So you are just giving you an idea of what is happening here. You are doing what you call, you are doing it's a global approach. You are analyzing the information that is given to you, and then once you've got an idea of the information that is suggested by your graph and what is given, you can come in now and try and attend to the questions. The one question is saying, which one of the following is true? We are looking for the truth. Okay, the value of the y at the turning point is negative. Okay, because you've already done your analysis of what is given to you. You have done a global approach, a global analysis. You can easily tell, Banamanga, my y-intercept is positive. There it is equal to 10. So this one is not true. We're looking at something that is true. Yeah, and then they say the value the value of the x of the vertex. Remember, the vertex is your x value of your turning point. Okay, it is the axis of symmetry. Your axis of symmetry will be this line. It is the x coordinate of your turning point. We've already identified that it is negative, and then Bonabati is positive. You can easily come because you've done your analysis already. Okay, the value of A is negative. Okay, from our analysis, we know if ever this thing is frowning, it's a frowning face, it is looking down. If your graph is looking down, it means your A is less than 0. That means it is negative. Okay, this is true. From all this information, we are getting it from your toolbox. And then the discriminant is negative. Okay, most definitely it is not negative, because remember, from our analysis, we said from our toolbox, we know we've got 2 real solutions. This thing is intercepting. When your things are intercepting your x-axis at 2 points, it means your discriminant is greater than 0. This is from your toolbox. So therefore, this is lie. This is lie. None of above. It does not really matter. So your correct solution will be equal to this one, without doing any calculation, just from your analysis. So it is important to first do your global approach analysis every time. It does not matter what kind of situation that you are in. Okay, here's another one. This one is saying, okay, this one we are saying here, here we are told we've got a quadratic function, okay, which is in this form. We are asked to find the discriminant. This is in a form a x squared plus bx plus c. Okay, we know what is our discriminant. Our discriminant is, your discriminant is equal to b squared minus 4ac. This is coming from your toolbox. So what is your b? Your b is negative 15. Okay, your b is negative 15 all squared, and then minus 4. What is your a? Your a is 4. And then what is your c? Your c is equal to 10. Okay, so look at your b. Your b is a negative number. It's not just 15. Negative number is a notorious number that you must always handle with care. Okay, so don't just take only the number, also take the sign of that number, that is negative 15. So you can just plug this thing into your calculator, which is going to give you 65. So if your discriminant is greater than 0, this is greater than 0, then you know, this thing has got 2 real solutions. It means you can go and find the solution of here, the x-intercept. Either you can use the formula or you can factorize. It will depend on the situation that you are in. Okay, so question 3, this is what this thing is suggesting. This is a quadratic form. You are told that this thing can be rewritten as y is equal to ax squared plus c, where the values of a, b, c. So you need to simplify. There's nothing that you need to do here other than simplifying. Okay, so to simplify, you're going to have your y minus 6 is equal to 3 into, and now we need to simplify here. Okay, I hope the masses know how to how to simplify here. We are going to use the distributive property, and or there's that method. Is it LIFO or FIFO? I don't know what it's called, but we are going to start by the first terms. The first terms is equal to x squared. The inner terms, it is minus 2x. The outer term, it is x minus 1. Which is minus x. The last terms, that is negative 2 multiplied by negative 1, is going to be positive 2. If, guys, you think, hey, I don't know, I forgot, I forgot how to do this thing, that means you've got a reason to book a consultation with me, so then I can take you through on how to do basic distributive property. So this is going to be equal to 3x squared. Okay, before doing that, let us simplify. It's always good to do these things step by step. So this is x squared minus 3x plus 2, y minus 6. So this is going to be equal to 3x squared minus 9x plus 6. I'm going to take that 6 that side, which is going to be equal to 6. So this is going to be equal to 3x squared minus 9x plus utwalufa. Okay, so I've got my thing there. So I know my A is equal to, 3, my B is equal to negative 9, my C is equal to 12. Okay, so that means this is your answer. So what was important here is for us to be able to simplify our equation. Okay, here's another one. The turning point, we need to find a turning point here. Okay, the turning point of this thing is equal to this. So remember, for us to find a turning point, we first look for the axis of symmetry, and the axis of symmetry, you've got your x is equal to minus b over 2a. Okay, you know that your a is equal to 2, your b is equal to 3, your c is equal to negative 4. Okay, so you can just come and substitute here. Your b is negative 3 over 2 multiplied by 2. This is going to be equal to negative 3 over 4. Okay, so this is only the x coordinate of your turning point. To find the y coordinate, you need to take this value and substitute it into your original equation. So you're going to have your y is equal to 2 into negative 3 over 4 all squared plus 3 negative 3 over 4 minus 4. Okay, so through the simplification, I'm not going to go through a simplification, guys. Through the simplification, you'll find that you get negative 41 over 8, which implies that this is equal to, because now, if you look here, you've got your x coordinate. It is negative 3 over 4. There is your negative 3 over 4, but you need to get your x coordinate, your y coordinate. So to get your y coordinate, it means now you need to, this one looks like a mixed fraction. So you need to attempt to write this thing as a mixed fraction. You say 8 goes how many times to 41? It goes 5 times. And what are you going to be left with? You're going to be left with 1 over 8. Okay, So now you can see, Guti, this is your turning point. All right. So it can look simpler to those who don't have problem with quadratic. Not all of us, we remember these things, guys. Okay. We don't remember these things. So that's why we take you through this. Okay. So here's another one. Consider a quadratic equation, which is this one. The x-intercepts are, okay? So we need to find the x-intercepts. Remember, what is the formula for x-intercepts? It is x is equal to minus b. We've got x is equal to minus b plus or minus b squared minus 4ac divided by 2a. Okay? That is the formula for our x-intercept. So here you know that your A is equal to -3. You know that your B is equal to 5. You know that your C is equal to 7. It's always good to take these values out of your equation. So once you are done there, what you need to do now is to find is to get these things into your formula. So what is your B? Your B is 5, so you're going to have -5 plus or minus into what is your B? Your B is 5 squared minus 4. What is your A? Is -3. What is your C? It is 7. And then you divide that by 2. What is your A? Your A is -3. The signs is very important, how you work with your signs. Okay, so now this is going to be equal to -5. You're always looking at the choice of your answers. Plus or minus 25. Okay, 25 plus 84 divided by -6. So this is equal to -5 plus or minus 109. Yebo? Or someone is talking, exciting. So now you look at this, okay? Look, if ever you've got something that looks like that, then you can see Guti Nance. Okay? It is just to know your toolbox. Once you know your toolbox, you can do anything with functions. Okay? Here's another one. Okay? In here, you are given, just by looking at this thing, I can analyze this thing, Mina, sitting here. Okay, I've got a quadratic equation. This is a quadratic equation. And then what can I, if I'm relating this is a symbolic form, this is a graphical form. From here, I know this is equal to y is equal to a x squared plus bc bx plus c. I know what is my y-intercept. My y-intercept is -3. So I know ukuthi lo b lona -3. I can just tell. I've not answered any question, but I can tell ukuthi lona is -3. And then and also I can also find, okay, I can also find my my A coordinate using the formula. At least I am happy with that. So without going and waste time and calculating things. So this is what I know, and I know what my discriminant here is greater than 0 because this thing is touching this thing at 2 points, and I know what if value A is equal to 1, I can see, and this thing is smiling. It's a smiling face. Let me go and answer the questions from the information that I've gathered from my toolbox. So the determinants of A is for the turning point. That means here I need my my x of symmetry. So I'm going to have x is equal to minus b over 2a. Okay, so here I know that my A is equal to 1, my B is equal to -2, my C is equal to -3. Okay, so now this is going to be equal to -2. I always like to protect my negative numbers because hey, they can bias you. So make sure you protect them. That's why I'm putting the negative number. So this is 1. Okay, so this implies that this is going to negative multiplied by negative is positive. I've got 2 over 2 multiplied by 2 is 2. So my x coordinate is equal to 1. Okay, same procedure. How do I find the y coordinate? I need to take this one and substitute it into my equation. Okay, so my y is equal to, my x is 1, you've got 1 to the power 2 minus 2 into 1 minus 3. Okay, this is equal to 1. 1 minus 2 minus 3. So this is simply equal to, is it minus 4? 3, 4, 5 is minus 4. So my TP is 1 comma minus 4. Okay, which is simply equal to this one. Okay, so you can see how you calculate the turning point. The process is almost is the same, not almost the same. Calculate the coordinates of C and D. Okay, the coordinates of C and D. The coordinates of C and D, these are the x-intercepts. Okay, so now to get my x-intercept, I need to get my equation. Okay, my equation is y is equal to x squared minus 2x minus 3. Remember, you've got two options of getting your x-intercept. Either you use a formula, x is equal to minus b plus or minus x is equal to, you can use this one, x is equal to minus b plus or minus so this is equal to b squared minus 4ac divided by, I mean, if you're struggling with C lento, guys, you think you are struggling with your factorization, you can use this formula. It's not a problem. But Mina, I can easily factorize this thing by inspection. Just by looking at this, I know in Toguti, I'm looking for the factors of 3. When I subtract them, I'm going to get to 2, just by inspection. Then I know I can easily factorize without using this formula. This formula is for when it's difficult to find the factors. But this one, I can get just by inspection. I can get in Toguti. I am looking for the factors of 3. When I subtract them, I get 2. That is 3 and 1. And then I'm going to give the bigger number a sign of the middle number. That means this one is going to get negative. This one is going to get positive. Okay, so I know what are my x coordinates. So from here, remember what we said when we had that intercept method. An intercept method is saying that for your x-intercept, because you're looking for an x-intercept, remember, for your x-intercept, you let your y to be equal to 0. So I'm going to let my y to be equal to 0. So I'm going to have x minus 3 into x plus 1. Okay, for me to simplify here, I'm going to use this property, which is saying if you've got AB is equal to 0, your A is equal to 0, or your B is equal to 0. This is a property that you find Lapagua mathematics. So here, I'm going to say my x minus 3 is equal to my x minus 3. My x minus 3 is equal to 0, or my x plus 1 is equal to 0. So therefore, my x is equal to 3, or my x is equal to minus 1. Those are my x coordinates. So now how do I write this thing? Remember, we said for your x-intercept, you let your y to be 0. Remember from yesterday, we said your x-intercepts, you are writing them in this form. Okay, so here 1 is going to be x comma 0. We are writing it in a coordinate form, or this one is minus 1 comma 0. Okay, so now we are looking for what is your x here. Your x is 3. Your x is 3. So I'm looking for 3 comma 0. There is your 3 comma 0 and minus 1 comma 0. There it is. So these are your coordinates. Okay. So that's one way. If you don't know how to factorize a simply algebraic expression, use use this one, it will get you to this, does not matter, but it's a longer way. So you need to be economical with your time. Only use a formula if ever you cannot get eland. Okay, so this is what I got from my things somewhere, just to pull everything together now. Okay. This question is helping us to pull everything together, the linear functions together with the quadratic function, and see them in one Cartesian plane. Okay, so now first thing, remember, before you do anything, look at what you are given. Okay, you are given all this information, you are given a formula, you are told go to your G is a straight line, you can see it's a straight line, and you are also given point A is equal to -2,4. Let us just play around with this and see if ever we cannot fill in any gaps. So we know Guti, point D, it is equal to 6. This one is 6. Based on this is easily, I can tell. And then the x-intercepts, one thing that you can analyze about this, your x-intercept of your quadratic, they are there's two of them, because it's a discriminant. This thing is telling us about the discriminant. Okay, the discriminant is greater than 0 because we've got 2 x-intercept and your A is negative. You can tell because this thing is telling you, and it's also together with your graph is showing you. So now we need to determine the x-intercept of your f. Your f is this one. We need to get the x-intercepts. So how do you get the x-intercepts? You've got your f of x is equal to negative x squared minus x plus 6. If you don't like f of x, uyakuphazamisa in your thinking. This is just equal y is equal to negative x squared minus x plus 6. You want to get x-intercept. Remember, to get your x-intercept, you let your y to be equal to 0. So this is equal to 0 is equal to negative x squared minus x plus 6. If you don't know how to factorize, use your formula. X is equal to minus b plus or minus square root of b squared minus 4ac. So here we can say this is x squared plus x minus 6 is equal to 0. This is a quadratic equation that we can factorize. So we are looking for factors of 6. When we subtract them, we are going to get 1. Okay, that is 3 and 2. 3 multiplied by 2 is 6. 3 minus 2, it is 1. So I can easily get my things here. So this is going to be equal to x and x. So this is 3. This is 2. It's going to be plus. This is minus. So your x plus 3 is equal to 0, or your x minus 2 is equal to 0. Therefore, your x is minus 3, or your x is equal to 2. Those are your x-intercepts. We are going to go and substitute this thing into our graph. So now this, because it's on you've got 0 on the negative side. Your B, this one is -3. Your C is equal to 2. Okay, you've got that one. They say write down the equation of your axis of symmetry. We know the axis of symmetry, it is x is equal to minus b over 2a. Okay, so now what do? We know from here, this is the equation that you are working with, your original equation. Okay, so here we know that our A is equal to -1, our B is equal to -1, our C is equal to 6. So that's what we know. So now you take that to substitute here. So this implies that your B is minus, so it's -1 divided by 2, your A is -1. So this is going to be equal to 1 over -2. So now your axis of symmetry, okay? So we are looking for equation of axis of symmetry. The equation of axis of symmetry is x is equal to something. So here, this is -1/2. Okay, this is negative half. It's your x of symmetry, is where you get your x coordinate. And then I'm not going to be talking about the range. Okay, I don't want to talk about the range. Your graph is running. Your graph your values is -3 going to all the values. Your x is less than -3. That will be your range. I'm not going to be talking about that because it's not for our terminology that you are using at this level. So your graph can run all the way, picking up all the negative values. Okay, all the negative values of your y. It can go on and on and on and on. So now what you can say here is your range is all the values is from here. This is the domain. I'm talking about the domain. This is a domain whereby your x is less than -3 for all the negative values. And then from here, this thing will run all the way where your x values are greater than 2. So now it is taking all this and then taking also the values between these two. So I don't want us to talk about the domain and the range. It's for another topic. What I wanted us to do is to pull together the equations, the linear equation and the quadratic form using our toolboxes. So now we need to write down the equation of a linear equation. How can we calculate the equation of a linear function? Go back to your diagram. Okay, a linear function is this one. We're born a linear function. Linear function, we've already written all of the coordinates. So we know our linear function is in this form. Your y is equal to mx plus uc. What do you know about the given information? I know what is my y-intercept. So I already know what is my c. My c is 6, so I've got mx plus 6. Okay, what else do I need? I need to get your gradient. How can I get my gradient? Okay, if you've got time, guys, you can go and calculate your gradient. If ever you cannot, you don't know any other method, you can get the gradient because you've got two coordinates here, and go and calculate the gradient and use the formula m is equal to y2 minus y1 over x2 minus x1, because you have this coordinate, you've got this coordinate, you can go and calculate your gradient. But you don't have to do that. You need to be economical about your time. So now what you can do here is to say, my line, this is this line. This line, it is this one. This line there, it is crossing at this point and also crossing at that point. Okay, I've already used this point because it is this one. I have another point that I can use. So I'm going to name this point my x, and then this one is going to be equal to my y, and take the x value and substitute it here and my y value, so then I can get my m. Okay, so let's do that. You're going to have 4 is equal to m, what is my x? Is -2 plus 6. Okay, so this is going to be equal to 4 is equal to -2m plus 6. Okay, so negative 2m is equal to 6 minus 4. So my 2m is equal to 6 minus 4 is equal to 2. So my gradient is just equal to 1. Okay, so now you've got your 1, so you go and substitute it here. So therefore, your equation of your straight line is y is equal to 1, which is going to be equal to 1x plus 6. We don't like to see a coefficient of 1. It looks so clumsy, so we just don't write 1. So you've got this. So this becomes the equation of your straight line. Okay, so a question can come in, okay, and ask you what are the points of intersection. That means you can get the values of -2 and this one, by simultaneous equation. Remember, I took you through the simultaneous equation whereby we did elimination and substitution method. But if ever you're going to be combining these two, you would have to use a substitution method because you are using one form, which is a linear, and also the one which is a quadratic. So you cannot do an elimination, okay? It can become tricky, not that you can't, but the best way is to substitute. So now that's how you would be dealing with these two when we pull them together. And the people that have helped with a one-on-one with the linear equations, you can easily see how we get the linear equations if ever you are given a point and a point and an intercept, or 2 points. Same procedure, same thinking. There's nothing more. And then write down the average gradient between A and D. Finding the average gradient, we are not there. A and D, to find the average gradient, it means we are finding this, okay? A change in Y and a change in X, okay? Which is the same as this one, which is equal to 1, okay? So we are not there. I just want to show you another example that I came across, which is pulling these things together. As an equation, same thinking. You are given a quadratic and also you are given a linear equation. Okay, so now you are given different points there. Okay, you are given your x-intercept. So now you've got this one, yeah? And then you've got this one. Okay, so you've got this, and then you've got that, and then you've got your t. Your t, you can see the coordinates. You are told what this is your, without saying a word, this is your y-intercept. So now this is your 8, okay, which is your range. Your range is running from 0 to 8. That is your range. And then, no, it is your y is less than 8. I'm not talking about the range today, but your range, it is this maximum point going down to the negative side, okay? So now your S is one of your x-intercept. Without even being told, you can see this is your x-intercept. And then your T, your y-intercept, your graph passes at R of T. So now that is the information that you are given. And then your A, you expect your A to be negative because this thing is frowning. What else do you know? Your discriminant is greater than or 0. That is an analysis that I'm just doing just by looking at the graph. And then what is the question? Okay. The diagram shows the graph. Okay, what was the question? I don't know what was the question asked because I don't have a question here. What was the question? I can help us to think about the question. We can find maybe a question can say, what is an equation of your linear equation? We can find this equation. Okay. You can find this equation. You've got your x-intercept, but now you don't have this one. So you'll be stuck here. If ever you are starting with y is equal to mx plus c. So now if you've got this one, the only information that you have here is equal to mx plus 8. Okay, so that's the information, the only information that you have. You don't know this one because you don't know the value of your x here. Okay, so now for you to find the value of your x, you would have to do what? What are the suggestions here? I don't know what is the question. I'm trying to gather the questions that can be asked here. Okay, so now I need to find my R and I need to find we are given this one. What is the value of our R? Can we find the value of our R? So these things are given in this form. Even your quadratic form is equal to y is equal to ax squared. Your q is just equal to 8. That's the only information that we have here. And we are stuck. We are stuck because I don't even know what was asked. I'm trying to find the equation. How do I find this equation? I can only use here. I don't know the question, guys. So I may have to abandon this question because I don't know the extra information that was given and what I'm supposed to find. But in any event, this is how you think about the quadratic. Able?
All right. And Kerry, you were saying we should find the equation for a straight line.
Mm.
Yes. I was thinking since we have the turning point coordinates, we might use them, but then if we use them,
Pardon?
it shows that I was thinking if then we can use the t coordinates to find the thing, to find the linear equation.
Yeah.
Yes. And we can still use both of them to find the one for parabola.
Okay, now this is where we are here. So we have used this one here.
Yes.
So what will be the next step to find the equation?
And already we know that 8 is our y-intercept.
Yeah.
Yes. And then we know that even if, maybe let's start with the 1 year parabola. Yes, the 1 year parabola, let's substitute with the as coordinates, the 1 year 2 and 0. Yes. So meaning that if we substitute with those coordinates, our y
for the parabola
going to be 0, and then a it's 2 squared plus, yes, on a parabola.
Yeah, you can find the equation of the parabola because you've got the turning point, and then you also have this one.
So 0 is, yeah. Yes.
Which is we can say this is ax squared plus bx plus c. Okay, we already know what is our c, which is our y-intercept, which is a, and then we can find the values of your a and the values of your b. Okay, so now what will be those values?
Yes.
What are those values?
Okay, now since well, we are not given b. As you can see that as they say that the diagram shows the graph of g of x is equals to ax plus q, meaning that we only have a and c. We don't have b. Yes. So I was thinking probably we could substitute with the coordinates of s, whereas our y is going to be 0. X is going to be replaced by 2 squared plus 8. And then it's going to be 0.
What is your 2?
My 2 is x.
Oh, here.
Using s intercepts.
You say y is equal to?
I'm saying, until we don't have b. Yes.
Yeah.
0.
Yeah.
Is equals to a into 2 squared. Yes. Plus 8, right? So first we have to calculate 2 squared, which is going to give us
what?
4.
Plus 8.
Yes, plus 8. Okay, then it's going to be 0 is equals to 4a plus 8. And then we divide both sides by 4. So it's going to be 8 is equals to negative 2. So now we have our
quadratic.
Yes, that's our quadratic. And then when we do our straight line, we can use the t, but then if we use t, it shows us that we won't have a gradient. But
you can find, maybe you can find a point here. If you've got this one, this can give you another coordinate of your parabola. So then you can have this point. Then if you've got this point, you can easily get your gradient. Do you hear?
Okay.
If you take this one and let
Knowing
this
that
thing to be
we
equal
can,
to 0,
yes, I can
your
hear
y,
you.
0 is
Meaning
equal
that
to
we can use
this one, this plus 8, ne? So your 2x is equal to 8. So your x is equal to plus or minus 2. So now we know with this one, the x coordinate is minus 2 because it's on the negative side. So your r is minus 2. Okay, so now you've got two coordinates. You can go and find what we were looking for. We're looking for rho m. You can get your gradient because you've got 2 points. So to find your gradient, you're going to have your m is equal to y2 minus y1 over x2 minus x1. What is your y1? Decide on which one you're going to make your y1. Let's say it's this 8. So you're going to have your 8 minus this one is going to be
R1.
Pardon?
We can use T as our y2. We can use 8 as our y2.
Yes. Are you clear?
Can you hear me?
Yeah, I can.
Yes, we can use 8 as our y2 and 0 as our y1. Yes.
So your thing is going to be 0. This one is going to be 0 minus which is plus 2. So this is going to be 8 divided by 2, which is equal to 4. So the gradient is equal to 4. So therefore, your y is equal to 4x plus 8. Okay. Okay. So this is a wrap.
Bye-bye.
Thank you so much. Bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye.
Thank you.